Okay, so today we're going to talk about systems of equations. There are two ways to solve a system of equations. The first method is called substitution, and the second method is called elimination. So I always say I am the messy math tutor because nothing is perfect. But that's okay because math can sometimes be messy, but as long as we get the answer, we're good. Okay, so substitution and elimination. For a system of equations, we have two options. And usually the way the problems are presented will give you the answer to which method should be used. So here's an example of a system of equations that would be given. And now when everything is nicely lined up like this, you can see the x's are in one column, the y's in one column, and the answers are in another column. I usually say that is a good indication for elimination because what we're going to do is eliminate one variable. And you will always be able to tell which one, usually you'll be able to tell which one would be easier. So in this case, we can see that if I were to add these two equations together, I could eliminate the y because they have the same coefficient. All I would have to do is multiply one by a negative or think about subtracting the bottom equation instead. So either way is easier. Sometimes I always like to add so that I don't forget. So I'm going to go ahead and make the top one negative, meaning I'm going to multiply the entire top by a -1. So to do that, I'm going to go ahead and make each one of these negative. So a negative times a negative, this one would become positive. And then my 11 would also become a negative. So now with elimination, I just go straight down. So I'm going to add, because I always like to add, I've already taken care of my opposite signs so that my y's will eliminate. So if I just add straight down this way, I have a -1 plus a -7. That would be a -8x. If I add the y column, plus 2y minus 2y, that's really 0. I don't often write that just because that's assumed, right? So that column would just be 0. And then I go ahead and write my answers here on the right. So I have a -11 minus 13. That would be a -24. So this works out for me. -8x equals -24. To solve for x, I'm going to divide both sides by -8. And that gives me x would be a +3. So now I have my answer for x. All I have to do is plug it back into either of these equations. I usually try to make less work for myself. So if there's one that has maybe less coefficients or whichever one's easier, I'll often do that one. So let's plug that into this top equation, and we can use the original that didn't have the negatives, or we could use the one that we had already made negative. So I'm going to use the original. So if I plug in x, I have 3 minus 2y equals 11. I just replaced the 3 wherever I saw an x. So then to solve for y now, I need to isolate the y. So I'm going to get rid of the 3 by doing the opposite. So I subtract 3 from both sides. That gives me -2y equals 8. To further isolate y, I'm going to divide both sides by -2. That would give us y equals -4. So that would be our answer for y. And what a system of equations means, especially for linear functions, I have two linear functions. If I were to graph these with their slope form, they're not in slope format, but wherever that is, I should put this where we actually know the solution to be. This is the solution, meaning 3 for x and -4 for y. That is my coordinate for the solution, and the solution to two linear lines is going to be where they intersect. So that point is at +3, -4. So wherever those two lines happen to intersect, if we were to graph those, their solution where they intersect would be 3, -4. So that's what the solution to a system of equation means. So let's do one for substitution. What I like to say is if one is already solved, meaning one variable is already isolated, already by itself, that is usually a good indication that you can use substitution because you just have less work. And quite honestly, both methods could be used in any case, just oftentimes one method will be easier than the other. So in this case, I already have y isolated. It was given like that. So now I'm just going to substitute this chunk for y wherever I see y in the second equation. So substitution, literally I'm substituting one variable, what it equals, into the other. Substitution. So this is substitution. I'm going to plug in this whole chunk for y into the second equation. So what does that look like? We have a negative 2x minus 3 times 6x minus 11. So that whole first chunk here, I'm plugging in place of y, substituting for y. So what does that look like? And then it still equals negative 7 over here. So I'm going to go ahead and distribute. So I have negative 2x. This would be minus 18x and a positive 33. And that equals negative 7. Now I combine like terms. Negative 2 minus 18 would still be negative 20x plus 33 equals negative 7. Then to isolate x, I'm going to subtract 33 from both sides. That would be minus 20x equals, this would be negative 40. And that works out because it works out nicely to a nice number. So we have, we're going to isolate x more, I'm going to divide by negative 20, divide by negative 20. X equals positive 2. Negative over negative is positive. So x equals 2. So now I have my solution for x. All I have to do is plug it back into an equation, and I want to solve for y, so I'm going to use this top one. I could use either equation. I just always look for less work for myself, right? So I'm going to go ahead and plug this value for x into that top equation for y. So we have, change the color here now, we have y equals 6 times 2, that's my solution for x, minus 11. So 6 times 2 is 12, minus 11, that equals 1. So our solution in this case for a system of equations, if we were to graph them, would be 2, 1. So that would be the place where these two lines intersect. So we had one line, and if we were to graph the other one, wherever it would intersect. So that would be our solution to this system of equations. X equals 2 and y equals 1. Some teachers would prefer you to draw it just as a circle, or as like circle your answers, or as a coordinate set. So 2, 1, x, y. So that would be our solution there. All right, so that is the two methods for solving a system of equations using elimination or substitution. So you can decide which one is easiest for you given the equations that you're given.